Hi, my name is Cody Hosterman, and thanks for coming. I'm the technical director at Pure Storage for VMware Solutions, and what I want to be talking about today is virtual volumes. Now, I don't have time to do a deep dive in virtual volumes or anything like that. I want to talk about a specific use case that I think is particularly important that really doesn't get brought up a lot. Right? People talk a lot about storage policy-based management, the benefits of the snapshot changes inside of virtual volumes, and the granularity of reporting and management and things like that. But I think there's a particularly important use case that sometimes gets, or pretty much always gets missed, I think, when talking about virtual volumes. And it's really about how it unlocks your data, really allows you to move the data in your VMs wherever you want. So let's talk a little bit about what this means. So this is kind of the full picture of virtual volumes, right? There's a couple pieces to it. It looks complex, but in reality, it's not. There's three parts to it. There's your data plane. There's your management plane, which is the VMware API for storage awareness. Right? And then there's your policy-based management plane, right? This is if you want to apply storage profiles. When you're provisioning a VM, hey, I want this VM to be replicated. I want this to be snapshotted once an hour, right? And that's the portion of that that controls it. But the data plane is sometimes misunderstood, but this is really one of the important parts of virtual volumes. And it's what actually allows you to move your data where you want it to be when you need it there, right? So let's talk about how this works. So first off, VMFS. Right. There's a variety of issues with it. It's been great for many years, right? Scalable, high performing, right? Pretty simple to set up and manage, but there's some issues with it, right? If I want to take the data inside of one of my virtual machines, how do I get it somewhere else, right? If I want to move it to a physical server, if I want to move it to the cloud, right? How do I do that? Well, you can use some host-based copy, and there's some cool stuff that VMware is talking about, of course, this week as well at VMworld. But if it's inside of a VMDK, if it's inside of a VMFS, and you want to use something like your array to move that data, it's not particularly easy, right? Because that data is locked inside of a VMDK file on a proprietary file system. And if you take an array-based snapshot of that, how do you send it to something that's not VMware, right? Or send it somewhere that maybe is VMware, but that's an older version or something like that. How do you do that? You're somewhat locked in. And this is why people would use things like raw device mappings, right? Hey, I want to move between my production and dev tests, and one's virtual, one's physical, or one's somewhere else. And so they have to use raw device mappings to move that data, and then you lose a lot of the benefits of the virtual SCSI stack inside of ESX and what VMFS provides around storage emotion and things like that. So let's just look at a simple example, right? If you want to do some dev tests with a VMFS snapshot, right? You literally just want to move your data into another place inside of VMware, another host or another VM, right? To recover a VMDK or a VM from a VMFS snapshot, right? You have to take that snapshot, present it to the host, then you got to do a rescan. And often in certain large environments, rescans can take a long time. At scale, this is a problem. Then you got to resignature it. Then you got to find that VMDK. And then you have to add it to that virtual machine, right? And to refresh it, there's a whole another set of steps you have to follow, right? Removing it, following all those steps again, then adding that VMDK back, right? And this is a lot of coordination required to do this, right? Some stuff from the storage admin, stuff from the VMware admin, or if it's the same person, they got to do two things in two different places, right? And there's a lot of plugins and orchestration layers that help automate this, but these steps are still required, right? And every time you have all these steps, there's more opportunity for failure. And of course, once again, it's still locked into that VMFS construct. And if you want to do dev tests from a VMFS snapshot to non-VMware, well, how do you do that? Well, we mentioned this a little bit earlier. You can use some host-based copy. You can use like a VM converter, right, to kind of move it, right? But it's not particularly easy to get that data out of your VM, leveraging, let's say, array-based replication or array-based snapshot, right, to get it to move it to, once again, the cloud or a physical server or something like that, or whatever your even a container, right, running somewhere. How do you get that data out of it? It's not particularly easy. And RDMs is not really a great solution, but that's kind of what we've stuck to recently. So back to virtual volumes, right? With virtual volumes, every virtual disk you have is a physical volume on the array, right? There is no file system in between your VM, your OS, right, and that physical volume, right? Every virtual disk is actually a physical volume, right? So the only file system on that is whatever your OS puts on it, right? NTFS, XFS, whatever, right? And so to bring up these volumes, or VMDK, right, to another VM or a physical server, you don't have to do any resignaturing. There's no copying of data, right? You can take a snapshot of a virtual disk and present it right up to a physical server, right? There is no VMFS on it. There is no VMDK file. There is no conversion you have to do, right? A big part of the virtual volume architecture was to keep these data path open, right? There is basically zero proprietary communication between VMware and that VM to the underlying volume, unlike with VMFS, right? It's a direct volume, but it gets all the benefits of virtual disk because it still goes through the virtual SCSI stack, right? You can do cloning, you can do storage vMotion. You cannot do that with RDMs from a VMware perspective, right? So this really opens it up. And furthermore, if you're presenting another VVol back to like a copy of a virtual disk or a VVol back to a VMware environment or a different one, there's no rescans. Right? There's only one physical device you present. It's called a protocol endpoint. All those VVols are bound through it as a subline. And so to see new VVols is just a SCSI inquiry, right? Which is far less expensive than a SCSI rescan. Right? So this scales up better, allows you to easily copy it in virtual environments. But what about moving it to physical environments as well? Well, as I mentioned before, VVols are T10 standards, right? The data path is standard. Right? There is no VMFS, there is no VMDK on top of it. Right? The only way a VVol is different than a regular volume is that it's a subline. Right? You have a protocol endpoint, which is kind of your mount point, if you will, and then VVol, which may be LUN ID 255, and your VVol is LUN ID 255:7. Right? It's attached through that protocol endpoint. That is the only difference from a storage perspective of a VVol and a volume. It's just how it's addressed by that host. So a volume could be attached to a VM as a VVol through a sublun, and then to another physical host as a direct LUN. Right, at the same time. Right, you could share a volume between a VM and a physical Linux server or whatever. Right? And snapshots also make this kind of an interesting use case as well. With VVols, when you take a VMware snapshot, it creates an array-based snapshot. Right, so you lose a lot of you remove a lot of all the performance penalties and so forth that you got with the traditional VMware snapshot you take. Right, VMware would even tell you, don't keep them around for more than a day. Right, even less, if you can avoid it, right? Because there are performance penalties to that redirect on write and all that type of stuff. When you right-click on a VM that's a VVol VM, it creates an array-based snapshot. And especially modern arrays, array-based snapshots are great, right? No performance impact. They're usually deduped, so there's no kind of capacity penalty, right? And they can be easily copied and maneuvered. Right? One of the features that we've announced that we're releasing pretty soon on the flash array from Pure is offloading array-based snapshots to things like NFS or S3. Right? So you could create storage policies inside of vCenter to say, hey, the snapshots for this VM, after a month or a week, I want you to send them to S3, right? And then move them to Glacier, right? And since these snapshots are just of regular file systems, one of the configurations for offloading snapshots is to kind of export it into a cloud-native format so it could be brought up in something like EBS as an EBS volume, right? Literally, your VMware snapshots can be leveraged inside of the public cloud to do your dev test or cloud bursting or whatever, right? Or the VVols themselves, they're just volumes, right? If you can do it with a regular snapshot, you can do it with a VVol snapshot, right? So your data is really only limited to where the array can send it to, right? So that really opens up a lot of possibilities, as I'm sure every vendor you talk to is going to be talking about integration with the public cloud and moving your data around, right? Everyone wants their storage platform to be that portal. And with VMFS, even NFS to a certain extent, that's somewhat difficult. But with VVols, because it opens up what a virtual disk is, this makes using these type of technologies a lot simpler. It's a lot less orchestration and no conversion that you have to do to be able to manage it. As long as that VM or whatever can read NTFS or XFS or whatever, it can see that VVol and leverage it. Right? And migration to VVols is also very simple. Right? If you want to get off VMFS, just storage vMotion. Right? Right-click on this VM, send it to a VVol data store, which is just a logical construct. Right? How do you restore a VM on a VVol data store? Well, if your array can, and some of the new arrays will have kind of recycling bins when you delete volumes. When you delete a VVol VM, those volumes can go into your recycling bin. And if you say, hey, I accidentally deleted it, go to your storage admin, they just need to pull it out of the recycling bin. It's immediately back in your VVol data store, and your VMware admin can right-click on it and register it back. Right? They don't have to do anything from the VMware side of rescanning or bringing up a new VMFS to get it there. And there's a lot of interesting benefits around just data mobility and recovery inside of VMware, and also due to the architecture of the data path, what you can do between VMware and anything else. Right? That's a big talking point of this entire conference, is moving your data around. And I think VVols, one of the most strategic features around it is really the data mobility that it offers for the data inside of your virtual machines. It removes that proprietary part of the data path. Right? So, quick summation, what's the call to action? Talk to your storage vendor about VVols. Right? VMware say, hey, it's up to the storage vendors to kind of discuss this. They see this as a core feature of VMware, of VSX. So they're not talking about too much because it's really about what the storage vendors can provide to you. So talk to your vendor about their roadmap, right, around virtual volumes, what they're doing, and how they can leverage this data mobility around it. Right? Think about the problems you have today. Right? Do you have rescan parallelization issues? Right? Do you have dev test snapshot issues where, hey, I want to bring up a bunch of these, but it's somewhat difficult because some of them are in production that are physical, or some of them are in virtual that are also is production, but I want to move it over here for dev test. It might be physical, whatever. Right? All kinds of crazy different mixtures. Right? Think about some of the problems you have around that. I can guarantee you that VVols can make it easier because of what they've done with this. Right? So I think it's just one thing. My last thought is just think about the issues you have and talk to your storage vendor about VVols. Right? I think it can probably solve it. Of course, there's a lot more information online about virtual volumes. There's a couple deep dive sessions, and I have a session tomorrow about Pure and VVols. And of course, if you're watching this online, Google VVols. I'm sure you'll find some stuff out there. But thank you and appreciate your time.